So we're given the voltage for a battery, and we are told the energy that the battery stores. So it says in the question that watt hour is an alternative unit for energy. And if you weren't sure why that is the case, think about the equation power is equal to energy over time, or work done per unit time. If we rearrange this for energy, energy is power times time. And the units for power is watts. The units for time is seconds, though it could equally be hours as well if we're not using SI base units. So energy can have units of watt hours as well. It tells us what 1 watt hour is in joules. Let's actually show how this comes about. So we're using the same equation, energy is power times time. And if we break down this unit, so we have our power, 1 watt, multiplied by our time, which is an hour. If we convert that to seconds, we get 3,600 seconds. And when we multiply these two things together, power times time, that gives us joules. So the unit for energy, the conventional unit for energy is joules. This will then be 3,600 joules. So we know that already. We were told that in the question. We are expected to then show that the energy that the battery stores is 25 kilojoules approximately. So we can then do 6.91, which is the watt hour that we have. And then we can multiply that by 3,600, because this is 3,600 joules. And that gives us 24,876, which is about 25 kilojoules. For the next part, calculate the maximum charge that the battery can provide. So we know that Q is equal to IT, but if we look at the quantities that we're given a voltage, 3.82 volts. We're given an energy as well, or a work done, and that is the 24.88 kilojoules, and that's it. That's all we're given. So we don't have a current, we don't have a time, so we can't use this equation, we have to find another one. We can use the equation potential difference is work done per unit charge, and then rearrange for charge. So charge is then work done over voltage, and that would be 24876 all over the voltage, which is 3.82, and that gives us 6,512 coulombs. So the quantities in our question are given to 3 sig figs, so we'll give our final answer to 3 sig figs as well. So about 6,510 coulombs. And for the final part, for A at least, for part 3, the mobile phone runs out of charge. Calculate the minimum time taken, so we want T, for the battery to fully recharge. We're given the current, so now it looks like we are using Q is equal to IT. We worked out the charge from the previous part, so Q was 6512, I believe. Yep. And then we can put that into the equation. So time is then Q over I, which will end up being 7,236 seconds, but it wants it in hours. So we can then divide this by the number of seconds in 1 hour. And that gives us 2.01 hours. So on to the final part. So we have a charging plug that came with the mobile phone. So that has a current of 1 amp and a voltage of 5 volts. So it's designed for those two values, for a current of 1 amp and a voltage of 5 volts. And then it's replaced with a similar charging plug, but now the current is a bit lower. So now it's 0.5 amps instead of 1, but the voltage is the same. So we're then trying to look at the benefits, the disadvantages, and the risks with replacing the plug with this one. So then one of the advantages would be that, or one of the disadvantages would be that it charges slower. So we still have to supply that same charge that we had before. It still has to get to a charge of 6,512 coulombs. But if our current is lower, then we will have a longer charging time, as Q is equal to IT and Q is constant. That means that if I decreases, T will increase. Okay, so it's a slower charging time. That could be a problem. It could also be a benefit, because if you have a longer charging time, the likelihood of the phone battery heating up would be lower, and that could increase its lifespan. In terms of risks, the phone, if this is the charging plug for the phone, then this is likely the current and voltage that the phone is used to getting. So it may be the case that the phone tries to draw more current from this charger, and the charger may not be suited for that. The charger may overheat, that could cause a fire hazard, so that could be one of the risks with using the replacement charging plug. So let's write that down.